All right, you already have all the tools necessary to do everything in this video. All right, we're going to be evaluating logarithms with our heads, with our minds. You can use calculators, but it's very good practice and it will help you later if you can do these without a calculator. Okay, so it's a very, very good idea to try to get good at these without a calculator. It's going to be very, very helpful in graphing, very, very helpful using logarithms and solving with logarithms later. Very helpful if anyone's planning on going into calculus and stuff like that. Okay, so it's a good idea to get a conceptual understanding by being able to do these with the power of your brain. So all this is going to involve is just converting things to exponential form, right? With one magic step, just like we did before, right? One magic step, we just get rid of the logs, and that's what we're going to do here. One of the big things for doing this by hand is remembering properties of exponents, right? If I have a negative exponent, that just means reciprocal. It's weird that negatives work that way, and there's a long explanation for why it works that way. It's not that long, but I don't want to spend time getting distracted on that now. And the other one is fractional exponents. This becomes the nth root of a to the m. Okay, if n is 2, it's the square root. For example, so let's do example 3. I don't know why the 3 is so small, but there it is. Simplify. Part A. What is log base 4 of 64? So maybe you know this, maybe you don't. But maybe you don't like logs very much. Maybe you love logs, right? Well, we can just convert this to exponential form. This is going to equals some number x. And I want to know what this equals, right? I want to know what x is. So what we can do is just go off to the side and convert this to exponential form. 4 raised to what exponent is going to give me 64? Well, 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. Oh, 4 cubed is 64. Ah, there we go. That's our winner. 4 raised to what exponent gives us 64? 3. We're going to say that this logarithm equals 3. Ah, there we go. This simplifies completely down to 3. Okay, let's do it again. Let's make it a little harder. Log base 3 of 1 over 27. How do you simplify this? Well, let's use the same logic. This is some number x. I don't know what it equals, but it's some number x. So we have to answer the question. 3 raised to what exponent going to equal 1 over 27. Now there's two things going on here. We've got a fraction, 1 divided by something. Using this little recollection thing, that 1 divided by something means we're going to have a negative exponent. So we know we have a negative exponent because fraction. October, don't you dare scratch that. Okay. I'm watching you. The negative exponent because fraction. So make sure to note this. So let's just make some guesses. 3 to the negative first power is a third. 3 to the negative second power is a ninth. 3 to the negative third power is a 27th. Oh, there we go. 3 raised to what exponent is 1 over 27? Well, 3 raised to the negative third power is 1 over 27. And just like that, we're done. Okay, so we're going to do some more of these as practice, and then remember that there is also the selected homework problems video at the end of the section. She's so adorable when she's not causing problems. Yeah, I'm talking to you. All right, let's do another one. She's standing on my notes. Part C. Wait, I literally can't see part C. It's behind her bottom. Excuse me, Octa. All right, we're just gonna make up part C. Part C is like right over there. All right, there's a new part C now. Okay, what about the logarithm base 8 of 2? We need to simplify this, so this is going to equal some number that we want to know. We want to know this number, we just don't know it. We're trying to simplify it. So convert it to an exponential form. 8 raised to the x equals 2. The base of the logarithm is the base of the exponential. The input becomes the output becomes the input. What's on the inside switches. Okay? 8 raised to what exponent equals 2? Well, it doesn't seem like anything, right? 8 to the first power is 8. 8 to the second power is 64. It's getting bigger. And negative exponents would give us a fraction. This is going to be a fractional exponent problem. Okay? So we have to think, what radical, right? Is there a radical that can make this true? Yes, the cubed root. So 8 to the 1/3 power equals 2, and this equals 1/3. Now these fractional exponents are usually the trickiest. There's another way of doing this if you really want to get creative. So there's kind of two ways of approaching this. Alternatively, I can't spell, whatever. You could write 8. 8 is the same thing as 2 cubed. How do you simplify that left-hand side? Right, this and this are the same. How do you simplify this? Well, an exponent raised to another exponent becomes 2 to the 3x equals 2 to the first. Again, this is kind of jumping ahead a little bit because all these sections are intertwined. And then you could get to the point, okay, well, 3x has to equal 1. So this is another way of approaching this problem as well. So x is 1/3. All right, October has deigned to give me my notes back, so we have 2 final problems. Part D. What is 2 times the log, base 2, of 1/32 plus 5? So you have to be very careful here. We cannot convert this to exponential form because this is not in logarithmic form. Logarithmic form is the log of something equals something else. But this, right, this is multiplication, addition, and a logarithm. So for this problem, what we do is we go off to the side and say, if we can find this logarithm, then we're basically done. I can multiply something by 2 and then add 5. So go off to the side real quick. Let's work on the logarithm. And then once we simplify the logarithm, let's put it back in. So on this red thing, let's just go off to the side and say the base of the logarithm is the base of the exponent. The input becomes the output and vice versa. And again, we got that fractional, so we know x is going to have to be a negative number. Turns out it's -5. And you can check this with your calculator, and you should check this with your calculator, right? Is 2 to the -5 equal to 1/32? All right. Do I have Desmos up right now? I do. Check it with Desmos. Right? So is 2 raised to the negative 5th power equal to 1 over 35? Oh, maybe. Is that 1 over 32? 32, not 35, yeah. So they're the same. All right. So, but we're not done. We showed that this red thing is negative 5. So that means we have 2 times negative 5 plus 5. But again, this is easy once you can remember to do it. That becomes negative 10 plus 5. All right. So it turns out we did have the right answer, but you still have to do these extra steps, right? It's still negative 5, but that's a coincidence. Don't forget those steps, okay? Multiply it by 2 and add 5. Man. Let's do one more in this video. Part E. Log base 3 of negative 9. So, of course, this is just going to equal some number x. So, just like before, blah, blah, blah. It's getting boring, Jason. Give us something new. 3 raised to what exponent is going to give us a negative 9? Nothing. This doesn't exist. Why does this not exist? Well, given as you're watching a video on 6.3, you're a master on 6.2, graphs of exponential functions. What does this exponential function look like? What does 3 to the x look like? 3 to the x looks like this. It has an asymptote at y equals 0. So we're asking, right? This is 3 to the x. We're asking, well, when does 3 to the x equal negative 9? Where do these functions intersect? Well, I mean, they don't. They're not even close. They never intersect. Remember that we can always use graphs to solve equations. Just graph the left-hand side, graph the right-hand side, and see where they intersect. So we actually can't take the log of a negative number. That means negative 9 is not in the domain of this logarithm. Talk more about domains in 6.4. Everyone loves domains and ranges, right? All right, so there we go. That's this video. Good luck.